Good morning, dear student. This is our second chapter of geography, and that is physical features of India. Physical features of India. सबसे पहले आपको फिजिकल फीचर्स का अर्थ समझना चाहिए. फिजिकल फीचर्स का अर्थ होता है प्राकृतिक विशेषताएं. प्राकृतिक विशेषताएं मतलब पर्वत का होना, मतलब किसी कंट्री में माउंटेन का होना, प्लेन एरिया का होना मतलब मैदानी प्रदेशों का होना, प्लेट्यू एरिया मतलब पठारी प्रदेश का होना, डेजर्ट एरिया मीन्स रेगिस्तान का होना, कोस्टल एरिया मतलब समुद्र किनारा होना, और आइलैंड मतलब पानी से घेरा हुआ कवर हुआ ऐसा एरिया का होना. Physical feature of India. In this lesson we will understand some physical features which are available in India. Now we will understand our first topic, and that is theory of tectonic plates. Theory of tectonic plates. According to the theory, the crust of the earth has been formed out of 7 major and some minor plates. यह थ्योरी के अनुसार पृथ्वी का भूकवच मतलब क्रस्ट 7 मुख्य और कुछ निम्न प्लेट से बना हुआ है. The movement of these plates caused the building up of stresses within the plates and the continental rocks. इस प्लेट के मूवमेंट के कारण प्लेट में और कॉन्टिनेंटल रॉक में स्ट्रेसेस मतलब दबाव तैयार होता है, और इससे रॉक में फोल्डिंग और वोल्केनिक एक्टिविटीज की क्रियाएं होती है. These plates can be classified into 3 categories. First, convergent boundary. Here plates come towards each other. इस कन्वर्जन बाउंड्री में दो प्लेट्स मतलब लेयर्स ऑफ रॉक के जो प्लेट्स बने होते हैं वो एक दूसरे के नजदीक आते हैं. सेकंड, डाइवर्जन बाउंड्री. हियर प्लेट्स मूव अवे फ्रॉम ईच अदर. इस डाइवर्जन बाउंड्री में जो रॉक के प्लेट्स होते हैं वो एक दूसरे से दूर चले जाते हैं. एंड थर्ड, ट्रांसफॉर्म बाउंड्री. Here plates may be moved horizontally past each other, they may be collide and crumble, or one may slide under the other. इसमें इस ट्रांसफॉर्म बाउंड्री में जो रॉक के प्लेट्स होते हैं वो डाउनवर्ड अपवर्ड मतलब ऊपर नीचे की तरफ जाते हैं. डियर स्टूडेंट, in the examination for 1 mark or for 3 marks question can be asked in exam. That is, what is meant by convergent boundary, or what is meant by divergent boundary, or what is meant by that is transfer boundary. Dear student, to understand our topic in detail, watch next video.
The Earth is a remarkable piece of real estate, and a busy one at that. From ever-changing weather patterns to the hustle and bustle of city streets, our planet is in a constant state of motion. However, if we take a look just below the surface, we find that things are always moving below our feet as well. It's called plate tectonics, and it's how the continents were formed and reformed and reformed. But before we get to that, let's dive underground to learn what our planet looks like from the inside out. Our Earth is made up of layers, and there are 2 types of layers we need to learn about in order to understand plate tectonics: the compositional or chemical layers and the mechanical layers. We could spend an entire session on what makes both of these types of layers unique, but for this lesson we're simply going to provide an overview. There are 3 primary compositional layers to the Earth's surface, and these are probably the ones you're most familiar with: the crust, the mantle, and the core. It's important to understand that the compositional layers refer to the materials or elements the Earth is made of. However, if we take a look at how the inside of the Earth behaves, we can divide them even further into mechanical layers. Starting from the outside working in, the lithosphere is the outermost layer of the Earth, which contains the entire crust and the topmost layer of the mantle. The asthenosphere contains the same materials as the top layers of the mantle, but the pressure and the heat are increased. It's not exactly a liquid, but it does move like heated rock, so you could say it's somewhat fluid. The mesosphere is next. At this level, the pressure is really starting to build, which restricts the molecule's ability to move, thus making it very, very rigid. Past the mesosphere is the liquid outer core. Extremely high temperatures melt the metals contained in this layer into liquid form. Think flowing rivers of lava, and you'll have a pretty good idea of what the outer core is like. And finally, we reach the solid inner core. Just like the liquid outer core, the inner core has extremely high temperatures and is composed of mostly metals, which might lead you to ask, why isn't it liquid as well? The answer is pressure. There's so much pressure at this depth that even though the temperatures are beyond the melting points of the metals contained in the inner core, the high pressure essentially squishes everything down into a solid. Now that we know a bit more about the composition of the Earth, let's move on to plate tectonics. Let's start with the history. In the early 1900s, a scientist named Alfred Wegener noticed that the coastlines of several continents looked like they fit together, similar to puzzle pieces. He believed that around 200 million years ago, all of the continents were joined together in one large supercontinent that he called Pangaea, which is Greek for all the Earth. Over the course of millions of years, Pangaea broke apart into the continents we know today, a process he called continental drift. Although his theories explain quite a bit about the origins of the Earth, scientists at the time weren't exactly impressed and initially dismissed his ideas. Fast forward to today, and Wegener's concepts are the basis of the modern-day plate tectonics theory. So what exactly is the plate tectonics theory? Well, it states that the Earth's outer mechanical layer, the lithosphere, is divided into large continent-sized plates that are constantly moving. How fast are they moving? Pretty slowly, actually. Around 1 to 2 inches per year, which is why it was so hard for scientists 100 years ago to wrap their heads around the idea. So what changed their minds? Well, a few natural discoveries in the 20th century made Wegener's theories seem more plausible. For example, in the 1950s and 60s, scientists discovered heated magma rising up through cracks in the oceanic crust called dikes, which is how new rock or new land is created. This realization that our planet is always reforming and reshaping itself from beneath lent credibility to Wegener's theories. Point Wegener. Not long after, scientists started plotting the location of earthquakes and volcanoes around the world and observed that the location of those events followed a similar pattern to the outline of the plates Wegener proposed. And then there was the fossil evidence. Fossils of tropical animal and plant species have been found in Africa and other places on Earth that are less than tropical. One plausible explanation was that Africa was once part of a larger continent that was home to these tropical plants and animals. Remember Pangaea? So in light of all this evidence, the scientific community started thinking maybe this Wegener fellow was actually onto something, which led to the development of our modern-day plate tectonics theory. So now that we know the history, let's dive a bit deeper into how it all works. According to the plate tectonics theory, these massive lithospheric plates are all moving in different ways, and how they interact with one another can have a huge impact on the Earth. Where these plates meet are called boundaries, and there are 3 kinds. Convergent boundaries occur when 2 plates are moving towards one another. Transform boundaries occur when 2 plates are sliding past one another, and divergent boundaries occur when 2 plates are moving away from one another. Let's take a closer look at what happens at each of these boundaries. As we said, convergent boundaries are when plates are moving towards one another. When the 2 plates collide, a couple of things can happen. One of the plates will dive under the other plate. It's usually the heavier, denser crust that dives under the lighter crust. This creates what is called a subduction zone. And the deeper under the Earth's surface that plate goes, the more pressure it creates. That pressure, coupled with a high heat, causes the crust to melt, forming magma. The magma presses up towards the surface, and voila, you've got a volcano. An example of this is the Ring of Fire, which is an active ring of volcanoes that encircles the Pacific Ocean. The other thing that can happen when 2 plates press into one another.
Now, very important topic of the lesson we will understand, and that is 6 important physical features of India. 6 important physical features of India. इस पूरे लेसन में हम भारत के 6 फिजिकल फीचर्स समझने वाले हैं। पहला फिजिकल फीचर है द हिमालयन माउंटेन। दूसरा फिजिकल फीचर है द नॉर्दर्न प्लेन्स। तीसरा फिजिकल फीचर है द पेनिसुलर प्लेटू। चौथा फिजिकल फीचर है द इंडियन डेजर्ट। पांचवा फिजिकल फीचर है द कोस्टल प्लेन्स। छठा फिजिकल फीचर है द आइलैंड्स। नाउ we will understand our first physical feature, and that is the Himalayan mountains. The Himalayan mountains. The Himalayas are the young fold mountains which are the loftiest and one of the most rugged mountain barriers of the world. पूरे विश्व में हिमालय पर्वत एज अ यंग मतलब युवा माउंटेन है जो ऊंचाई में काफी बड़ा है। दे आर 2400 किलोमीटर लॉन्ग। देयर विथ वेराइज फ्रॉम 400 किलोमीटर इन कश्मीर टू 150 किलोमीटर इन अरुणाचल प्रदेश। लंबाई में हिमालय पर्वत 2400 किलोमीटर तक फैला हुआ है और हिमालय पर्वत की विड्थ मतलब चौड़ाई जो है वह 400 किलोमीटर कश्मीर में है और 150 किलोमीटर अरुणाचल प्रदेश में है। द हिमालयस हैव 3 parallel ranges in the longitudinal extent, namely फर्स्ट हिमाद्री जिसको ग्रेटर और इनर हिमालयस भी बोला जाता है। सेकंड हिमाचल जिसको मिडल हिमालयस भी बोला जाता है। थर्ड शिवालिक जिसको आउटर हिमालयस भी बोला जाता है। द हिमालयस कैन बी डिवाइडेड इनटू 4 सेक्शंस। हिमालय पर्वत 4 विभागों में विभाजित किया गया है। पहला है पंजाब हिमालयस। दे लाई बिटवीन इंदस एंड सतलज रिवर्स। सेकंड कुमाऊं हिमालयस। दे लाई बिटवीन सतलज एंड काली रिवर। थर्ड नेपाल हिमालयस। दे लाई बिटवीन काली एंड तिस्ता रिवर्स। फोर्थ आसाम हिमालयस। They lie between Tista and Dibang rivers. Watch our next video to understand information on Himalayan mountain.
In this module, we are going to learn about the Northern Mountains. The Northern Mountains. The Northern Mountains stretch across the northern boundary of India. They include the Himalayas, which are the highest mountains in the world. The Himalayas stretch in a long curve from Jammu and Kashmir in the west to Arunachal Pradesh in the east. The east-west extent is 2,500 kilometers and the width varies from 450 kilometers in Kashmir to 160 kilometers in the northeast. They form a natural boundary between India and China. Many Indian states are found in the Himalayan region. These states are Jammu and Kashmir, Himachal Pradesh, Uttarakhand, West Bengal, Arunachal Pradesh, Sikkim and other northeastern states. The Himalayas can be divided into Himadri, Greater Himalayas, Himachal, Middle or Lesser Himalayas and Shivalik, Lower Himalayas. Did you know Himalaya in Sanskrit means the abode of snow? It is given this name because a large part of the Himalayas is covered with snow all year round. The highest peak of the Himalayas is Mount Everest, 8,848 meters, situated in Nepal. The Himadri. The Himadri is the northernmost range. It is the highest range with an average height of over 6,000 meters. The mountains here are always covered in snow. Some of the highest peaks such as Kanchenjunga and Annapurna are found here. As it is very cold here throughout the year, it is very difficult for people and animals to live in this region. Cultivation is not possible in the mountainous region. In some places, huge masses of ice called glaciers that move down the mountain slopes are found. When these glaciers reach warmer regions, they melt and form rivers. The region receives heavy rainfall. The Himachal. This range is found between the Himadri and the Shivalik. The mountains are not as high as the Himadri. These ranges have some beautiful valleys such as the valleys of Kashmir, Kullu and Kangra. The beautiful hill stations of Shimla, Mussoorie, Nainital, Almora and Darjeeling are located in this range. During summers, people love to visit these hill stations to escape the heat of the plains. Some important mountain passes such as the Rohtang Pass of Himachal Pradesh are found in this region. The Himachal range has thick forests covered with pine, oak, deodar and fir trees. Climate in this region is suitable for cultivation. Winters are cold but summers are cool and pleasant. The lower slopes of these ranges have orchards and in the east we find tea plantations. The Shivalik. The Shivalik form the southernmost and the lowest range. These are hills rather than mountains. The slopes are covered with thick forests and many varieties of wildlife are found here. Much of the land is used for growing crops such as rice, potatoes and maize. The slopes of these hills are used for terrace farming, building a series of steps in the slopes of hills for growing crops. Cattle rearing is also common. The region to the south of the Shivalik is called the Terai. It is a flat, marshy area where crops such as rice, wheat and sugar cane are cultivated. In the northeast, the hills are not very high and are covered by thick forests. The hill ranges here include Garo, Khasi, Jayantia, Naga, Lushai and Mizo hills. The importance of the Himalayas. The Himalayas act as a natural boundary and have protected us from foreign invasions since times immemorial. They also prevent the cold biting winds of northern Asia from entering India. They also prevent the rain-bearing winds from leaving India, resulting in heavy rainfall over the country. The forests of the Himalayas provide us with valuable products such as timber, medicines and other forest products such as resin, honey and so on. The melting snow of the Himalayan glaciers provide water to our rivers throughout the year. Many animals are found here such as the snow leopard, tiger, rhinoceros and wild yak and so on. In this module you learnt that the northern mountains stretch across the northern boundary of India. The Himalayas are found here. The Himalayas have three ranges: the Greater Himalayas, the Middle or Lesser Himalayas and the Lower Himalayas.